tough ones are left. So, yeah, but definitely healthier today.
Okay, well, that's good to hear that there is some progress. I want you to tell me a bit about your research. What are you working on right now or have been working on earlier? Do you want to start?
Yeah, I can start. So I don't actually do research now, but I did my undergraduate degree in molecular biology, and then I did research at the Norwegian Radium Hospital, where I did cancer research mainly. Very basic cell biology, looking at functions of different proteins, trying to understand what goes wrong in cancer. But then last summer I decided to try something else. So now I work, I don't do research, but I work to stay updated on everything that sort of happens at the forefront of biotechnology and how that kind of meets the regulatory system that we have. That's my main work.
That sounds cool. You just get to keep up with everything.
It's fun.
How about you?
I'm working as a part of a large research group. We are also finding new and exotic ways to battle cancer. Currently, we are investigating a peptide, which is sort of a small molecule, which is capable of preventing the stress response in cancer cells, because we know that some of the cancer cells, when they're exposed to chemotherapy, which is designed to kill them, of course, has a stress response which increases their survivability. So in a way, we are trying to cut the fire alarm in the cell so that the cell does not recognize it is being attacked by chemotherapy, and therefore the cancer cell is unable to mount a response to the DNA damage. And so far it is going very well. We are expecting to see some steps towards clinical research later this year or earlier next year. So yeah, in a way I'm also in cancer research. And however, we have recently discovered that this peptide, aside from being capable of preventing the stress response in cancer cells, also prevents certain types of stress response in bacteria, which have a similar approach. They discover they're being targeted by antibiotics. They initiate their stress response mechanisms, and we are sort of trying to prevent these cells, be it bacterial or cancer cells, to know that they are under attack, to detect the source of the chemical stress before, to prevent them to detect the source of the stress before they mount a response to it.
So you're kind of tricking it.
Yeah, so we are making a big bag of tricks for the cancer cells and the bacteria, yeah.
Good plan. So you mentioned antibiotics. There has been a really big, a lot of attention towards antibiotic resistance, because antibiotics has been our friend for many years now, but new research says that by 2050, 10 million people would die a year due to resistant against antibiotics or the resistant bacteria. How did this happen, and how are we going to solve this?
Well, you may notice that if you abuse your friends, they're not your friends anymore. So it's pretty much how this happened. It is a beautiful yet terrifying example of evolution. So we have been fighting bacteria with antibiotics, and we've been tremendously successful at that. We've exterminated virtually all the bacteria which were sensitive to these antibiotics, so now we're left only with those which have developed resistance.
Is there any chance these bacteria might come back? So we will have like a renaissance for the old diseases?
Well, those which are sensitive to the antibiotics are obviously not our problem. They will appear, we will defeat them, and that's how it's been going on forever. However, when you are powerless against a certain type of bacteria, when you don't have an adequate antibiotic for it, it is already your problem. So as we speak, there are bacteria which we don't know how to kill, which can in turn kill us. So this is already here. How much it is going to escalate, we don't know. It's like an arms race. So you develop an antibiotic, a resistant strain of bacteria appears. You develop another, another bacteria appears, and then it goes on into this vicious circle.
So what can we do then?
Just smile and wave. We can try to keep up with the arms race. However, bacteria do not rely on funding and other things that we are very, very reliant on. So they have a very cheap workforce, which only requires glucose and amino acids. We are not that cheap, so we either have to put our price down or to increase the funding.
Okay, so there are ways to solve it. It's not like doomed. We are not doomed in a way, or do we even know?
If you assume that there is a bacteria which develops this super resistance to antibiotics, you will have a big problem. You may lose 90 or 99% of the human population, but evolution goes in such a way that once you have exterminated all that is exterminatable, whatever survives is stronger, better, and has better survivability. This is how we have evolved during the Black Plague, in the Black Death in the Middle Ages. A lot of European population and a lot of Asian population was affected by the plague. Today we see in the survivors of that age, we see a different and improved immune response to this type of pathogen. So evolution goes through extermination, unfortunately. How far that extermination is going to go, we have to see. But we will not be exterminated, if that is the question, as a species.
It's good to know. I want to talk a bit more about cancer, but firstly, I want to know what's the difference between cancer treatment and cancer therapy? Is there a difference?
No, not necessarily. The therapy is a kind of treatment, but what you can distinguish between is cancer prevention and cancer treatment, because there are ways to prevent cancer occurring in the first place, or there are ways to treat it if it appears. So,
in which way can we prevent cancer? Is it just the same old eat healthy and stay healthy?
Yeah, well, we know a lot about how cancer arises. It's mostly because you get damage to your DNA. And there are different ways that can arise. You can, I mean, this is typically, you probably know this very well, but sun exposure, cigarettes, all that kind of thing. But there are also, of course, things that you cannot control at all, because you do get mutations every time your cells divide, and so there's always a risk. So it cannot be 100% preventable anyway. But yeah.
So you might call it luck if you don't get cancer, or unlucky if you get cancer.
Yeah, to a certain extent, it's a matter of luck. But we know very well that environmental factors do influence cancer risk quite a lot. So yeah, there are still things to do.
Okay. What's the major problem areas in the cancer research right now?
I think so. We have now a lot of therapies that are quite effective for a lot of cancers, but for a lot of patients, you can take out most of the cancer, but then it's again a problem of resistance, because you will have some cancer cells that have developed resistance to the treatment that you're using. And as soon if you have eliminated all the exterminatable cancer cells, you are left again with the ones that are not. And those are difficult to treat. So I think that's our main problem, because cancer cells are very different. You can have cancer arising from one cell, but then they will develop differently. All the cancer cells will have different mutations. It's difficult to target. It's not one single disease. It's a very heterogeneous disease.
So
that is, I think, the key point to understand, that cancer is not one thing. It is thousands of different types, and every cancer is a story for itself. We have general families of cancers, if you want, but there is not one solution for all. So.
What types are the most aggressive ones or what families are the most aggressive? Or what is the most risque, or the worst
ones that are difficult to treat?
Yeah.
Well, it depends on the nature of the cancer. Some are difficult to treat because they are inaccessible. If you have a brain tumor, it's harder to treat than if it's in your blood, for instance.
Or some can be really fast progressing.
Yeah. If you have a mutation that makes it kind of divide really fast, then that's
Or
worse.
if your immune response is compromised, also, I think you're in a big problem. But you're in a big problem anyway. So yeah, but different. Yeah, it depends from case to case, really.
So the solution is a personal treatment, personalized treatment.
I think a lot of people are optimistic that in the future we will have personal cancer treatments where they look at your particular tumor, they look at exactly the mutations that characterize that tumor and develop a personalized therapy. But we are not there quite yet. It's a long road ahead, I think. To get there.
It's the financial aspect mostly, because you would need to sequence every cancer and then see what is it. Sometimes it's not in the sequencing at all. Like sometimes you can have an aberrant system of I don't know. Post-translational modifications which are not working as they should, or exposure to latent radioactive thing somewhere in your organism so you don't see the mutation right away or stuff like that. So it's also expensive to characterize a cancer.
Okay, I want to ask you, why are you working in Norway? Why did you choose to work here?
Well, the thing about science in general, you cannot sit in one point and then expect to have fresh ideas. It's like you're a frog and you're sitting in a pond and you're expecting that something new will come by. At one point, you require fresh ideas, and researcher mobility is extremely important. If you look at, for example, how microorganisms move around, there is no such thing as like we had the example with the SARS virus a couple of years ago. There is no such thing as a local outbreak. Outbreaks are usually global. Pretty much the same is with ideas. You never have an idea which is like stuck in one place. You have to move around to see, to experience different ideas, to get different ideas, to see how people are working, how people are dealing with different problems here and there. So apart from my obvious love for salmon, the other big reason why I moved to Norway is because the logistics which follows the science, and that is funding, researcher mobility, access to resources, access to people from other countries, from other ambients, is better here. But it is also better in many other places. So I don't think that anybody who has the ambition to go seriously into science should stay in one place. In ancient times, I think in Greece, it was also mandatory that people travel around. And we should use our ability to travel today around the world to experience new things and get new ideas, because I think that only by getting new ideas can we build upon what we know today. Recycling the same old ideas is not what bacteria and cancers do, so neither should we. If we, of course, have any intent to survive it.
So why did you choose to work on cancer, other than it's being needed?
Yeah, all the other jobs were taken.
Yeah.
Well, I'm a child of two engineers, so I have this engineer approach to problems. How does this work and how can I break it? My personal field of expertise and interest are poisonous substances, toxic substances. So how can a system be broken with least damage to the surrounding areas, and if you know how a system works, then you can see its weak points. In cancer, cancer is a beautiful puzzle. It's a bad thing to say that something that kills many, many people every year is beautiful, but in a mechanistic sense, in how it's organized and how it works in its very intricate details. Cancer is beautiful because it has found a way to survive and surpass the other cells of an organism, which tell it you shouldn't continue to divide, kill yourself, and the cancer says, no, I won't. And keep in mind that there is no such thing as a consciousness inside a cancer. So it cannot willingly decide, I value my life and therefore I will survive. There is something wrong in this very fine mechanism. And the mechanisms are what drives me to deal with cancer. Because it is this cancer cell, which is fighting for life, is the product of nearly 4 billion years of evolution directed at one thing, and that is survival. And seeing that on a molecular level is, to me, it is enchanting.
What about you?
I have a similar reason, actually. I think that cancer is extremely fascinating because it's, in a way, it's a byproduct of the very fundament of life. It's because we are reliant on cell division to survive, but it's also what goes wrong in cancer. And to understand that difference is really interesting. So that's what brought me to cancer research.
I see.
Yeah, just as a very short illustration, there is a protein in each and every of our cells which is called the P53. It has one purpose, and that is to protect the cell from accumulating genetic damage. And it works beautifully. It just stops the cell division in case there is a lot of damage, gives the cell time to repair, and then if everything is okay, lets the cell live. But it does the exact same thing in cancers. If a cancer cell is under attack by chemotherapy, the P53 protein stops the cell division, gives the cell time to repair, and then lets it run its course. So something which is evolved to protect us from damage is also protecting our cancers from the damage that we're trying to make. So this is a very deep irony on a molecular level, that you have this system which works perfectly at a very wrong time. So it's a beautiful illustration of why cancer is so fascinating. It just wants to survive at any cost. So.
And it's also, it's not being selected against in an evolutionary context because it's mostly a disease of old age after we have reproduced. So that's why we have also a lot of cancer.
Okay, so what you said about us getting older, it also makes us have more cancer.
Yes, it does. If you don't die from other things, then you will get cancer because it's just statistics and biology, basically.
So that's the answer?
Yeah.
You will die from cancer? Well then, goodbye. What about treatment? If we, I read that we are now discovering cancer earlier. How does that affect the treatment? It's quite a rhetoric question.
Well, prevention is great. You can drink vitamin juice and antioxidants and everything. But once you discover you have cancers, you should do exactly the opposite. So you should drink super fried oil or something. So these things that prevent DNA damage are counterindicated once you have a cancer. So then you should try to damage it as much as possible. Early detection is a great thing because, for example, if you have a localized tumor which has not yet started to spread to the other parts of your body, you just cut that off. So by amputating the cancer, you amputate the problem before it is escalated. And that saves, I think, the most lives today. So you have some bump on your body that shouldn't really be there, check it out. You have a mole which is behaving strangely, check it out. Okay, don't go into a panic and don't drink whatever remedy you read on the internet will stop cancer. Don't do that. Check it out. If it's a cancer, get it out, and then you're done. So you're a cancer survivor right away, and it's not even dramatic. You don't have to go through chemo and radiation. But the thing is that most of us won't bother to go to see a doctor because it's probably a zit or something. So early detection is fantastic. If you don't get it early, if you don't discover the cancer early, then you have to open the medical books and get some serious weapons. And then it's less convenient.
Okay, let's move on to biotechnology. What is biotechnology?
Well, it's a way of using our biological systems in an applied way. Then it can be used for industry or for medicine or different applications.
Okay, so what is then gene therapy?
The gene therapy is, well, the traditional gene therapy that was first developed about 30 years ago is based on adding new genes to your cells to cure disease or to treat something. And typically it's been diseases where you lack something, where you have a gene that's not functioning right, and then you can replace that, or not replace it, but you can add in a functional gene. And there have been some success stories, but there have also been some quite unfortunate events in the development of those gene therapies where you have had side effects that were not anticipated, if you like.
What types of side effects?
Well, the first children that received gene therapy, they had their immune system didn't work properly. They had new genes inserted, but the genes inserted in places in their DNA where it affected cancer genes, so they got leukemia. Some of these children, but on the other hand, they had a deadly immune failure disease. So it was portrayed maybe a bit wrongly in the media, as I think those kids, because most of them were then treated for their leukemia, they ended up in a good place after all. So I think. Despite everything, it was a good option for them to have that gene therapy. But there was one patient who was in a clinical trial for a different disease. He died from the side effects. But there were some problems because he shouldn't have been in that clinical trial. There were things with his condition that made him actually unsuitable. But it got a lot of media attention, and then people didn't really want to develop gene therapy anymore. But now it's coming back full force.
Yeah, a new discovery has been the CRISPR technology. Can you tell me what is it?
So 4 years ago, there was a paper published. There were some quite clever people who had understood that they could use a molecular system from bacteria to cut DNA. And whereas the old gene therapy technology was based on adding in new genes using viruses, this molecular tool allows us to edit the DNA in a cell to make quite precise changes. You can cut away DNA, or you can add in new DNA, or you can change pieces of DNA. And it's quite remarkable, this new molecular tool. It's versatile. It works in all different kinds of organisms that they've tested, and it's cheap, relatively cheap to use, and it's quite easy to use as well. So it really is starting to become quite pervasive.
How can it be used then?
Some people seem to think that the sky is the limit here. You can make the changes that you want to an organism, be it humans or plants or animals or microorganisms, to either give them new traits or take away traits. So it can be used for research, and it can be used for developing new medical treatments or new organisms with new traits in food production, for instance. Quite a few applications.
But how realistic is it, considering other gene therapeutic methods have been discovered and promised to change the world really rapidly?
So I think the main, there are two things. So one is that you have the versatility now to make the changes that you want. So before, if you had a mutation that would cause disease, you couldn't really do anything about that, because the old gene therapy technology, you could just add in new genetic material. But now with CRISPR, you can actually change the mutation itself. So you can take away disease-causing mutations, for instance. And the other thing is that it's cheap and easy to use. So whereas the old technology was mainly restricted to a few specialist labs, now people all over the world are using it. So things are moving really fast.
So when can we be able to see treatments using CRISPR?
So the first clinical trials have actually started. So in China, and later this year in the US, they will be using CRISPR to tailor immune cells to treat cancer patients. So I think it's lung cancer in China and a few other cancer types in the US. So they change the genes of the immune cells to make them more potent and better able to take out the cancer cells of those patients. And then also there are a lot of other diseases that will start up their clinical trials quite soon, I would think. What examples are eye diseases that cause blindness and blood disorders and things like that. It's coming quite fast.
What about genetic disorders?
Yeah, that's so everyone's wondering about this because there are a lot of serious genetic disorders that we really have no treatments for, like Huntington's or muscular dystrophy, things like this. And finally, we have a tool that actually allows us to do something about those mutations. And the big question is, can we do that to patients that are already ill? So it will be difficult to treat, for instance, neurological diseases like Huntington's, because the brain is difficult to access. But other diseases might be more targetable. So, but what's special about CRISPR is that it also works in germ cells, which are sperm cells, egg cells, and embryos. And researchers have tried now in mice, and they show that you can actually then correct disease mutations before you're born, and then you don't get the disease at all. So that's the big ethical question that we now face. Should we start meddling with germ lines or not?
A good question with the ethics, because if you are talking about editing an embryo, then you are already setting the life for these children with the DNA that they will get. That can't, or maybe it can be changed back, but it's not that easy. And then we will make this embryo, this child, will make it means to an end, not an end itself, which is the regular philosophical questions. What do you think about that?
That's a difficult question. I think when it comes to disease prevention, I think ethically a lot of people don't necessarily see that that's a bad thing to do that also in the germline. But I think a lot of people are scared of where it's going to take us next. So one thing is to cure a disease, but what if we start then doing edits that have less to do with disease, and then maybe enhancement, and it all kind of gets messed up in one big ball in this discussion. So, yeah.
But do you think it's realistic that we will have this society where perfection is the new, and there is no place for the human errors, and we have this designer children?
Personally, I don't think it's going to happen anytime soon, for several reasons. One is that genetics is very complicated. When it comes to disease, we often have a single or a few mutations that we can pinpoint and say that this is what causes that disease, and we can change it. When it comes to qualitative traits like intelligence or looks or whatever, it's a completely different ballgame. There are lots of different genes that interact to actually decide how that trait. And it's going to be difficult to do that with genetic editing. And even if it's possible, I think society, I don't think it's necessarily an automatically downhill slope. I think we can decide where to stop. And I think it's going to be quite far in the future before we see designer babies.
Yeah, I would also make a parallel. When Wikipedia was first organized as a free encyclopedia, which anyone can edit, and as you know, it's grown pretty much since then. It was initially criticized because there was no way an encyclopedia that anyone can edit could work. In theory. In practice, it does. So sometimes we're not able to predict all the outcomes. I think that it would be perhaps best to go that way carefully and then see what happens. Because we can easily envision worst case scenarios and best case scenarios, but there is a whole plethora in between of different scenarios which will take place. So caution is advised, but paranoia is not.
If you had to put a line on what we can edit of genes and what's not, where would you put it between treatment and then enhancing, for example?
In the germline, you mean? Or for the individual?
For the individual.
I think for the individual, if you treat one person, because if you treat the germline, it's going to affect all the descendants of that person. But if you treat a single person, I don't think, in terms of disease, there are really not many ethical questions, because if you have a disease, then you're willing to take some risk to treat that. When it comes to enhancement, it's difficult to draw the line, because a lot of conditions are, you cannot really classify it as disease or enhancement, and typically it comes to aging, which is not necessarily itself a disease, but it involves a lot of disease, and treating those, are those treating aging or not? And I think it's difficult to draw a clear line here.
So you think it will be possible to stop aging?
I don't necessarily think so, but a lot of people do.
What about you?
Yeah, I'm still thinking, I think. Yeah, well, it depends how you view these things. If we, for example, have a father and a mother deciding to have a child, and they are both carriers of a defective gene which may really make problems for this child, maybe even endanger its life, which is a situation that friends of mine unfortunately had, I would definitely say, yeah, edit out those genes and remove the disease, remove the defective gene from the gene pool. Although I must remind you that what we today consider as defective may be an evolutionary advantage tomorrow. So perhaps if we have people with 6 fingers and a virus which kills people with 5 fingers appears, and then, what is the advantage? But let us say that you have a really serious problem which is incompatible with life. So a child would not live past 2 or 3 years. Then definitely, yeah, of course, it is. I think even a right of the parents that want to have children, that want to have a family and offspring. They would have the right to remove this defective gene, and that would give them healthy offspring. When it comes to more delicate things such as enhancements, and still I agree that it would be difficult to say what is an enhancement, like is eye color an enhancement, or is IQ an enhancement, or is height, whatever. There are societies where, for example, alcohol dehydrogenase would be considered, that is the enzyme that breaks down alcohol, would be considered a disadvantage or an advantage. Like some people would get drunk from smelling the cap of the bottle. Some people would not be able to get drunk at all. So these things are very delicate. But let us say that it boils down to the question, how extensive is the authority of parents? Okay, so they have the possibility to affect their children and their grandchildren and their grandchildren's children. So, and you can say, well, yeah, okay, it's their lineage, so they can do whatever they want with it. But also you have to remember that in a couple of generations, their contribution to that great-great-grandson would be very, very small. Are they entitled to affect the life of that individual and all of its offspring? From that point on, I would prefer not to answer. These are difficult questions that would have to be answered by big, maybe even popular votes, because opinions of an individual may vary. I wouldn't have a problem editing my child's DNA because I don't really care about my great-great-great-great-grandson. But then again, maybe I'm a psychopath, and then I shouldn't be allowed to have children at all. So yeah, well, these are questions which probably vary from person to person. Again, they're not a 1 and a 0, because we could get down to very interesting questions of especially what is enhancement. So, yeah. Although knocking out a person's alcohol dehydrogenase would definitely be so much fun, but maybe best not to do it yet. So.
Yeah, because diseases or traits that we think are healthy or unhealthy, that has also varied a lot. Like homosexuality was seen as a disease, and even homesickness or nostalgia. So I don't know if we are even ready for this. Do you think that there is some that it's going too fast, the development, or do you think it's like the next evolutionary step for us intelligent species?
Now you've touched one of my very sensitive areas of interest. The very definition of disease, in my opinion, is controversial, at least. So what we say is healthy and unhealthy may have terrible consequences for the future of human race. Last time we did that on a large scale, a lot of people died. So while I say that we can probably agree that not being able to repair your DNA and dying at the age of 4 is unhealthy, the question is also, does our intervention alter the course of evolution? Okay, so the child which bears this unfortunate mutation would probably die before it would give its own offspring. But if you have a person which has, for example, a type of cancer which causes it to develop massive cancers at the age of 40, after it is reproduced, if you have a person like that, is that person healthy or unhealthy? Is health the ability to produce offspring? Or is health something which decreases your own quality of life? The question is, are we talking about the disease of an individual or the disease of the species? Because if you look from the aspect of the species, this person which is doomed to die at 40 is perfectly healthy. It did its own job. It produced offspring, and that offspring will likely produce offspring and also die miserably at the age of 40. So this individual, in terms of being a member of a species, is healthy. It does its job. It can be a fantastic teacher, researcher, whatever. It will just die at 40. So if this individual wants to live further, then this individual will say, okay, I'm sick. So I would like that my children don't have to deal with this. But you cannot know if this quirk in their DNA, which makes them die at 40, for example, makes them super resistant to many types of flus and viruses and whatever. So again, it is a very sensitive topic. What is a disease? What is this thing that you would or would not genetically alter? Is it really something that is a disease, either to an individual or species, or is it a new step in the evolution which just needs a couple of more generations to show itself in its real power and potential? When first apes were born without hair, I'm pretty sure they had really cold winters that they would have to deal with. But on average, it turned out that they could save a lot of protein by not covering all of their hair with all of their body with the hair, and this gave them certain evolutionary advantages once the ice age has passed. So it's really difficult to say what is a disease and should it be treated. So,
what do you think?
Yeah, I agree. I mean, it's difficult to classify. But what I would also like to just highlight is that we tend to differentiate between doing something to our genes and doing something by other means. So we treat disease if we want to treat it. Is there a principal difference between doing it genetically or doing it by other means? People are disagreeing on this because genes is kind of the holy grail of life, and that should be kind of left alone. But I agree. I mean, if you have a 4-year-old who is going to die from some serious, I think most people will agree that that is a reason to intervene by any means, probably.
Yeah, I heard a nice comparison just about the thing that you mentioned. Like, if we would consider trimming our nails a disease, why not amputate our hands? You know, so it takes away the problem. So maybe some diseases don't need such a drastic approach as editing the gene right away. Maybe people can live with therapy. You know, so it just depends on how hard you want to hit this problem and how debilitating this disease is. If you have to like transplant organs and waste millions from the public healthcare system on this one individual, yeah, well, maybe then it makes sense to just edit out the gene. But then again, you don't have to reach for the biggest hammer right away. Some diseases can be treated over a period of time with a relatively high success. So,
I wonder how, if this technology will develop in such a way it can be used on a general basis, where will it be? Who will have access to this technology? Who will be using it? Do you think it will be a division between the rich and healthy and the poor and sick? Or do you think it will be used as to make vaccines to treat, for example, HIV?
Yeah, I think it will be used for a lot of different things. But it comes to therapies that are more advanced, where these technologies meet immunotherapy, for instance. I think that will be mainly for our part of the society and not necessarily globally. But as a tool to as a biotechnology tool, I think it will be accessible in all different parts of the world in the coming years. I think there are now programs to start training communities in developing countries to use the CRISPR tools to improve their food, for instance. So I think it depends on what aspect you're looking at. When it comes to medical therapies, I think first is going to be the more privileged parts of society that will access this, but we'll see how it develops.
Just to add a little bit to it, experience has taught us that any new technology first gets developed within those circles which are secretive and poorly controlled, with high funding. Typically, this is the military. Then it progresses onwards to other applications. I would expect to see the same trend here. Maybe not in the military that much, because that's a little bit dystopian, but in a way I would expect to see closed circles with huge funding and very little control being the first ones, being like the hackers, which will take this problem and play around with it first. Maybe in this case that would be the highly funded scientific community in the States, because they have a lot of free space, a lot of room to experiment. Then, as with any other technology, there will be a very sharp divide between the rich and the poor, but as it was demonstrated previously, it is likely that this gradient will slowly melt away as this technology penetrates further into developing societies, developing countries. And then where it goes from there is anybody's guess, I think. So I just hope that during that entire process, the people who start playing with it first, which have the privilege to be the leaders in setting up a technology, will also have the common sense to define guidelines and to share not only their success stories, but also their failure stories with the people who are developing the technology later. Because whenever you have a new technology, the success story is just as important as the failure story. So the things that you tried and where you failed, but that is a big problem in the scientific community anyway, because unsuccessful research doesn't get published, and many people have to make the same mistakes over and over again. So I just hope that by the time that this powerful technology sees broad use, some of these issues will be dealt with.
But what about vaccines and epidemics? Is it possible to use this technology to treat it?
I have a very short answer to the issue of vaccination. Get vaccinated. So I know that a lot of people are trying to produce controversy where there is none, but vaccines are awesome because they help us cheat the bacteria and the viruses that we're supposed to deal with. Then you asked about, I didn't really understand, about the role of genetic modification in vaccine production.
Yeah.
Or,
is there any connection?
Yeah, I can
not
add to
that I
that.
know of.
Yes, I mean, so this CRISPR tool is part of, is also going to be part of the toolbox for something called synthetic biology, which is you engineer genetic circuits in microorganisms to make them produce stuff, basically. It can be anything from biofuels to vaccines, for instance. So that's one thing. And researchers are trying to develop ways of using CRISPR to reverse them, to attack bacteria, actually to, for instance, cut out their antibiotic resistance genes, which is also relevant in this context. You asked about HIV as well. They're using CRISPR and other gene editing tools to try and treat HIV patients, to either cut out the HIV DNA from affected cells, or to because we know that some humans have natural resistance to HIV because they have a genetic variant that makes them resistant. So if you can edit this into HIV patients' blood cells, then you can make those blood cells potentially resistant to HIV. And this is also kind of nearing clinical trial stage. So there are many ways to use this technology to treat. But one of the most radical ways of using this technology when it comes to epidemics, for instance, is to use it for something called a gene drive, where it's a way of spreading the genetic edits in wild populations. And researchers have now made this gene drive system to take out the malaria mosquito, to eradicate it. And it works in the laboratory. And they're debating now whether the gain of using this will be high enough to risk putting it out in nature.
What can the consequences be then?
Well, if you take out a species, then who knows?
To put it out in the...
Then it will, in theory, the genetic modification that will, it makes the mosquitoes, the females, sterile. So you will take out the population over time. It will spread out through the wild population of mosquitoes, and then rendering them unable to breed, and then they will die out. So, and then they cannot carry malaria, of course, and then hopefully it stops the spread of the disease. So that's the idea.
But there are also hypothetical risks, like maybe a virus hijacks the system and then infects a bee, so you also wipe out all the bees, which is like really bad. So runaway genes are extremely dangerous because we don't have enough data to know how genes move around in ecosystems, because while the majority of genes is conveyed through reproduction in one species, and there is also evidence that genes can go between species, usually carried by viruses or mobile genetic elements and stuff like that. So incredibly dangerous at this level of our knowledge, or lack thereof, to let modified genes out into nature.
Yeah, they only have a few sort of proof of concept studies now in the lab to see that it works on small scale.
Yeah.
But even trying to do a field trial, which is the natural next step, if you want to do anything with a genetically modified organism, is also dangerous, of course, because you cannot really control what happens. A mosquito. You can try stop it at the border and see what happens. Yeah.
Maybe like issue them little micro mosquito passports so they can...
Yeah.
Okay, if you picture 100 years ahead, do you think there will be any diseases that are exterminated, that are gone?
Well, in my opinion, most of the diseases will be exterminated in 100 years because at this rate of global warming, the human race will be largely exterminated. No, just kidding.
I think it's difficult to answer. So Mark Zuckerberg and his wife, they have decided to exterminate all disease by the end of the next century or something. I think it's not as simple as that. I think it's difficult to predict how biology evolves. It's like this arms race that was mentioned before. I mean, how we affect things, I don't know. And I think we will probably be able to take out some disease, but then maybe we will have new ones. Who knows?
What type of new diseases do you think? Is it
no idea.
impossible to answer?
Yeah, well, I didn't know about Mr. Zuckerberg being so ambitious. Like that's really lovely. Maybe he didn't study biomedical science very much. Well, yeah. Whenever you have a disease that you exterminate, like you have to die of something. So if it's not global warming and nuclear holocaust, then it's likely going to be cancer because you are destined to rot away at some point.
What about diseases of affluence, diseases that you have from poor health, like heart conditions or obesity? Is it more...
Sorry, I just have a thought to the previous question. I know there is one thing that we won't die of, and that is bacterial infection. Because as I said earlier, it may wipe out like 99% of us, but we also evolve, albeit slowly and not as fast as the microorganisms, but evolution still goes on even within humans. So I'm pretty sure that while we may be endangered by microorganisms, they are likely not going to exterminate all of us. Like even HIV, which is a really big problem, there are already strains of humans which are resistant to it.
So we out-resist the resistant bacteria?
We could, yeah, our immune system can theoretically give a response to resistant bacteria. Maybe not yours or mine, but like maybe there is one person in Oslo which could be super resistant to like the most dangerous bacteria that could evolve. Unfortunately, only that person would survive. So that, in that sense, the species is not endangered as long as there is a lot of us, and as long as we are as different as possible. If we were all very homogeneous, then we would be endangered. But fortunately, the human society is different enough, both genetically and culturally and geographically. We are different enough to assure our survival.
But what if we edit our genes so we'll become the same?
As long as diversity is preserved, our chances of survival are high. If we all decide to have like long brown hair, maybe we are not that secure anymore. So the more diverse we are, the better.
Yeah, but we also know this. We know inbreeding and genetic homogeneity is not good for any species. That's why the banana is going to disappear soon, because it's really, they're all the same.
Yeah.
So,
it's all one big banana. There is no diversity between bananas.
But you mentioned breeding. What's the difference between traditional breeding and biotechnology, or using the genes?
Using for plants and animals?
Yeah, or for humans even, yeah.
Well, that's a technical question. So when you have breeding, you have mixing of genetic material in through something called also recombination, where genetic elements they mix. But when we use gene technology or biotechnology, we do it more, targeted. We know exactly which traits we want to change, so that's the main difference between it.
Okay. What about the question about the heart disease or the diseases from lifestyle?
So heart disease is something that has gone down quite radically over the last years, because we have, it's partly because we know how to prevent it, but also we have good treatments now for it. But there's an interesting case. I mean, if you want to really stop heart disease, there are certain genetic variants that we know are very protective. People who have certain specific genetic variants, they hardly ever get heart disease because they have low cholesterol or whatever. So if you want to then edit that into the population, maybe we can stop, heart disease. But is that medical treatment or is it enhancement or was it? Yeah.
Good question. Now we have come to the end of this session. Lastly, I want to ask you guys, if you had the opportunity of knowing what you will die from and when you will die, would you want to know, or would you like to live and find out in the end? Now we will have a 10-minute break, and then we will have questions from you. So, yes, thank you so much for now.
Thank you.
Has it been an hour already?
Time flies.
This couch is
Yeah,
super
it's good.
cozy. I'm taking it home.
Huh?
I'm taking this home.
You're taking it home on the plane?
It's really heavy.
Cozy, yeah.
Would you like anything else? Anything more to drink? Peanuts?
No, I'm allergic to peanuts.
Okay, then no.
That's one of my punchlines, when it comes to disease. Am I sick? Like, because,
How do you define disease?
well, I have this one lecture that I Yeah, sure.
Most of the people here are my family.
Yeah, sure.
I would like, if possible, to keep in touch with you.
Yeah, sure.
Do you have Facebook?
Yeah. Let me type.
You know that a certain friend of mine, he believes that he has some very interesting opinions that he's being watched on the internet all the time.
There you go. Just add that he's being watched on the internet all the time.
Yes, whatever he does, people doesn't exactly have an interest in him, but they will, if they want to, they can still can.
Yeah. That is absolutely true.
No, I think you would like it.
Everything that you do on the internet can be tracked.
And here's the thing, I can't exactly say no, it can't, because it has been proved.
Yeah,
with
it's
Edward Snowden, right?
yeah, it's super easy. If you're interesting to someone, they can follow you, no problem. Like you leave a huge trail behind you, and that's not even going outside of your cyberspace. People usually don't have to get out of their chairs to track you.
So, do you think that it will get a new breeding ground for new kinds of criminality with all the new technologies regarding, daily life? Mobile phones to take care of your bank account.
It's here already, if I'm not wrong.
Will it improve on that point? Because they say that you don't worry about we will have all these secure systems in place that will protect you.
Well, somebody would have to go through a lot of trouble to really follow you. You'd have to be super interested.
So unless you're cooking like a barrel of plastic explosives at your home and you're planning to blow up the parliament, which I suppose you're not.
I'm looking at diaries of Islamists.
Yeah, well, sure. I mean, you have a Pakistani background, so you're probably like definitely up to no good, because you wear a beard, dude. Like you're about to blow yourself up. That's just
it's my nature, dude.
That's racial profiling. So yeah, in the U.S., I suppose you would be randomly searched many times. These are just some of the things we have to live with. I get searched often at airports because I'm coming from Serbia, and Serbia was bombed. So you just you try not to care about that. As long as you're not doing anything illegal, you have nothing to fear. However, what is illegal can be maybe it is illegal for you to vote for a different political party. These are the questions of the totalitarian government. However, I think that at this point you should not be worried about being watched or whatever.
That's Martin. He's a medical student.
Hello.
Psychologist.
Yes, my bad.
Yeah, well,
I tend to mix those.
The psyche is also a part of an important organ in our organism. So yeah.
But I think the veterinary conversation had quite an interesting intersection, because you were talking about the totalitarian system.
Oh yeah.
How did you get into that?
I jump around topics a lot. I'm not a one-trick wonder, so I'm in a lot of things. I'm not just epistemology. It can get very exotic if you go down that way. Like what really qualifies as. So as I was saying to him just a second ago, like he has a disease. The giants of Illinois. Researched every time he goes into the U.S. and this will significantly decrease his blister on his toe. You know, so after walking all day. Yeah, I have, I think, a statistically significant difference between what happens when I travel shaved and unshaved. So it is a simple thing. Also, if I'm smiling while I'm traveling, and if I'm like I'm working while I'm traveling. Super family, yeah. But yeah, you just don't pay attention to these things. However, if you do have to do something which is illegal in the jurisdiction that you're living, not going into it as ethical or unethical, because there are some pretty stupid laws. There is a law in Switzerland which says you cannot use a shower after 10 or toilet because the water obsesses the readers, whatever. So let's not go into what is ethical or legitimate or illegitimate, but if you are dealing with something which is illegal in the jurisdiction that you're living in or having to deal with, then you would have to go through increased secrecy. And there are ways to do that, of course, but that's IT. That's the Onion Protocol, the Tor, and the other. In terms of what? I know that when I travel, I noticed when I travel with Brunust that I always get searched. But I know why is that, because Brunust has a higher percentage of nitrogen than regular material, and the neutron source which exists in the scanner is actually increased amounts of nitrogen, and it's also neatly packed as a block posted when I buy it. So yeah, that's why I get it. So I cannot even begin to imagine how exotic certain methods are, because like that has to be somebody but okay, I understand. And still, you have to understand that a very motivated person can take down an airplane with a pencil. It's really not a problem. However, you cannot break it with a generic pencil. So the idea is to reduce the risk as much as possible. Therefore, it comes up with a lot of false positives and Well, take off your shoes, stand on your feet, you know, like, it's really nice. Like, usually what our guys do. They are old school, you know, they're old school. And they're like, but you have, you have 2 fingertips. What do you mean with 2 fingertips?
Sonic guys, he was big teams, he was looking at it, and then he gets on there, but everyone else that only do it, or we assume they do it to eat it themselves.
Yeah.
So they're like searching everything and destroying everything and take all the good stuff from it. But what danger can a chocolate eater take?
Yeah, we've had incidents of high quality barbecue meat being taken by whatever, Norwegian customs. So, yeah, well, these things happen. I mean, I understand if there is like an outbreak of a disease somewhere and you bring disease food or whatever, but it really doesn't work like that. You know, like by carrying meat, you won't prevent the disease.
Okay,
if there is. It happens. Well, it happens both ways. Not to me, but to a friend of mine. He lost like a kilo of first-class hamburgers ready to be grilled because they were not EU. But like, then it gets absurd because Serbia is the land of absurd stuff. It is on the border with European Union. So Croatia, which has the exact same legislation, we were like the same country 20 years ago. Croatia has the same legal system as Serbia. However, their meat is magically okay while ours is not. Or their driver's licenses are magically valid here while mine is not. So, on a systemic level, it is a method of producing pressure on Serbia to join the European Union, to like have your driver's license valid. I understand that, but still, like I am not unable to drive a car because I live on the other side of the border. And like, I've been driving a car since I was 18, so that's almost half of my life, and now I have to take the driver's exam here, and like the instructor is younger than me, and I'm like, that is not how you start a car when you're like pushing it, you know, or something. So it creates funny situations, but fortunately life is absurd as it is, so I just enjoy it. I'm there in 5 hours. The train ride from Trondheim here took longer than the plane ride takes from Trondheim. I mean, you have to understand that maybe while you're young, it may appear to you that you can change the world. However, as you grow older, it is the world that changes you. So you just find a way through those cracks and around those things.
Look at personality developments. People have tendency to, get molded by the roles they step into. For example, you are researchers and your tendency to curiosity, intellectual consistency will get back to the process. Hopefully.
Yeah. That's how it goes. You know, so you can even keep fighting the windmill. But if you keep fighting the windmill wins in the end because it always comes around and hits you. So you can try to be a revolutionary, you can try to make social change, but unless you are part of the majority, I mean, I've seen it in my country escalate into hideous violence. When you try to change the world, or in Skyrim game, as the dragon said, like the more you push onto the world, so does the world push back on you. So it's just a cost-benefit ratio. Partner? No. But that is my deeply... Skyrim is on, yeah, of course. No. Yeah. No, I have this propensity to hate humans in general. So I was like, a dragon versus a bunch of humans, that's an easy decision to make. Yeah, like so. Yeah, but that is because of my misanthropic nature. Yeah, I think I'm greatly disappointed by the humans because the majority of them are not as awesome as they could be. So, yeah, I don't know. I used to be an idealist, but now I'm just a nihilist. But maybe that is the fate of every idealist to become a nihilist. Yeah, we have a saying like a pessimist is an optimist with experience. Yeah, that's true. The pessimist is an optimist with experience. That's a sad thing to say.
Hello? Hello? Hello, are you ready?
That got their attention, I think.
Good choice. Okay, then we will start again. If you have a question, maybe it's easy if you just raise your hand and then maybe address who you are asking, or if not, that's okay too. Yes?
I can start.
Yeah?
So I have a question regarding like the relevance of the research you do and like the research you know on a global perspective. Because now we're asking what you dive from in a Norwegian perspective, but there are many diseases, many things you die from in developing countries that are easy to treat, but we start researching too late, or the research we do here in Norway, it's not, it's too expensive to actually implement in developing countries. So, do you get like where I'm comment on that?
Yeah, absolutely. Yes, you're right. It's a priority question. I think a lot of people think that, especially research into cancer and the things that are typically old age, extending our final years of life, in a global perspective may not be the best priority, because there are people dying from quite fundamental things around the world. But I don't think it's that one excludes the other. But I think we have a way to go actually in distributing also the research funds for things that are more typically for the developing world. So I agree with you there.
Coming from the developing world, I have this. I've had the unfortunate circumstance of my life to see how things work in a healthcare system, which is fundamentally identical to Norwegian, but with much less funding. So back home, we also have general healthcare, like you're covered from birth to grave. However, the funding does not allow for a high-quality service which exists in Norway. And that is a very unfortunate and very real circumstance of life. So money is important. When you live in a society which is capable to provide all of its citizens with an adequate healthcare system, it is easy to assume that every human life is equally valuable. However, as the resources grow shorter and shorter, you start understanding that not every life is equally valuable. There are circumstances in which elderly people, once an emergency call has been issued, for example, to the ambulance, the emergency services take a lot of time to respond, or maybe not respond for hours, because they are busy saving younger people's lives, or people who are there is like a triage, which is done at a very basic level, so even before there is a response. So this is a very real circumstance of life. You cannot financially protect all of your citizens, and you have to decide who is more important.
In terms of the availability of research and therapy, the good thing about research is that, especially today in the age of internet and the age of open access, you can have access to high-level research without much auxiliary funding. There are many situations in my country where doctors take their own independent research into a particular topic because they have access to all the scientific research in the world. And they act upon those new discoveries right away. So the implementation is much faster if there is enough funding. Some of the treatments, some of the new treatments, for example, cancer, rely on drug combinations. So they're not like a super fancy, super expensive new drug, but they're like a combination of earlier drugs, which are available. So nothing is stopping the doctor from just making this combination of drugs and starting the patient with the new combination of therapeutics. So in that way, I think it is important to emphasize, especially for the developing countries, it is important to emphasize the need for an open access to journals, open access to knowledge. Sci-Hub, which has hacked a lot of closed journals, has given a tremendous boost to these. I don't know if you're familiar with Sci-Hub. It's a girl from Kazakhstan. She devised this platform which basically stole all the available journals from many different institutions in the world, making somewhere in between 47 and 48 million scientific research papers available to the general public. So if you go to a journal and then you see that you have to pay to read some research, this kind lady actually stole all of that. So she's like a modern day science Robin Hood. There are many mirrors because some countries are making these sites illegal, or especially in the US there's a lot of legal issues. But communication of knowledge is free. And that, I think, can be one of the weapons in the reduction of this gap between the rich and the poor. Of course, if there is like a super new, super fancy and super expensive therapeutic, you cannot really have it right away in developing countries. But there are things that we can have available today. New protocols, new drug combination research, and so on. So that can reduce this gap in the rich versus poor, and that can make less of a difference in how much lives are worth. So that's sort of the deeper perspective, but I think that is important, especially in new treatments which rely on therapeutic combinations rather than new drugs.
Anyone else? Yep.
I know you're not economists, so if this question doesn't feel relevant to you, you can just ignore it. But there is a fundamental problem connected to what you're asking about, that there is funding, a lot more funding for developing medicines or treatments for the diseases that rich people have, not that poor people have. And what work can we do in creative incentives for both researchers like you and private pharmaceutical companies to create high-impact medicines that are not as financially viable? How can we incentivize them? How can we make them save lives, basically? Do you have thoughts on that?
You go first. I'm not going to be short about it.
Yeah, I'm, like you say, I'm not an economist, but so I think it's difficult because in the end it's business. Developing drugs, it's business. But I think a lot of the funding that goes now into research in drug development also has a strong component that is called ELSA, which is an ethical side, and also RRI, which is responsible research and innovation, which often then incorporates these kind of aspects. So how can you disseminate your knowledge to a wider audience and to benefit as many people as possible, and also to have them programs for distribution outside of the typical Western society. So I think we're seeing it more and more. I don't know how you would incentivize them more, but yeah.
When Alexander Fleming discovered penicillin, he said, let it be open source. So anyone can make it. There is not a patent covering it, so, discovering new therapeutics is extremely expensive, and it takes a lot of time. Therefore, it is only fair that a pharmaceutical company which decides to produce it can make profit off of it. So we don't make a question, why is the bakery profiting off the hunger of the people? Somehow it comes intuitively to us. Well, yeah, people are hungry, they need to pay to eat. It should also be as intuitive with pharmaceuticals. You can say, oh, but you're profiting from the sick people. In my opinion, the bakery is at a much worse situation there because everybody experiences hunger. However, only few people experience disease. So I would say that the profit of pharmaceutical industries is legit, as long as it is sustainable. The problem with many drugs is that their production is not sustainable. It drains the resources. For example, if you have a drug which can be sold to patients in Norway, of course the price is going to be insane, because it's not the customer, the individual that is paying for it. It is the big system of social security which exists in Norway. So in a way, you're not draining anybody of a lot of money, but you're draining this system that everyone has contributed to, so it's kind of not as bad. That's not true. It's extremely bad. It's even worse. So it is not justified to have different prices at different countries, and this is a huge issue. It should be taken on by the United Nations, if you ask me. The solution would be in making, first in outsourcing the production, because the production of these drugs is not that expensive as the development. If a system of healthcare, for example, the Norwegian state, finances the research that brings about a new drug, I think that it is imperative that this price, which has already been paid for, is deducted from the final cost of the drug. It's like paying for the same thing twice and taxing the same thing twice. This is not sustainable. It is like Norway is paying scientists to produce a new drug, and then this new drug is sold back to Norway at an insane price. So Norway pays for the same drug twice. If you want to push that further, you could instate, let's say, a fund at the level of the United Nations, which would finance drug development. And therefore, you could just say, okay, this is the money that we have all invested, and the development of this drug has been paid for by all of us, so therefore we're not going to pay an insane price, but rather just the cost of the production and the logistics. So in an economical business plan, that would be ideal. However, this is yet not an ideal world, nor shall it ever be. So we must take on these problems one problem at a time. Alexander Fleming did a phenomenal thing. He never made profit off it. And I would very much congratulate, in that case, those people, those anonymous beneficiaries that supported Alexander Fleming's research. So it should probably be a clause when you sign an agreement for funding that any discoveries that you made have already been paid for and not by you, so you don't get to profit off of them. Rather the country or whoever financed you. Ideally, it would be a universal thing. Ideally, it would be some United Nations fund which would invest. However, we are far away from that, especially because not everybody has the equal opportunity to participate in drug research.
Yeah, that's it.
It's a question about antibiotics. As I perceive the situation right now is that antibiotics is being overused because the burger has to cost $1 or less. And I know about antibiotics that there are several different types. Some are more used than others, and those who are not are backup antibiotics. So can you tell me what the situation is right now? Because I have started noticing that the articles talking about this team have started increasing. Is this the new cancer, in a way, or future main problem?
I have a very, very short answer to that for a change. My wife is working at the hospital pharmacy. Every day they're issuing more and more vancomycin packs. Vancomycin is currently the last line of antibiotics. So we have very few antibiotics today that can treat multiple strains of bacteria which are resistant to multiple antibiotics. Vancomycin is one of them. So in the Trondheim hospital, one of the things that is issued more and more often is the last line of antibiotics. It is only a question of time when a patient will come in who will not respond well to this antibiotic. And the bacteria will just say, I have evolved. It takes about 5 to 15 years to put out a new drug onto the market. It takes 20 minutes for an average bacteria to double its number. You see the discrepancy. So currently we are losing the race, but maybe there are new tricks up the sleeve that we can use. Yeah.
Is this where I said, oh shit?
I think that would be appropriate. Yeah.
Yes, there was a question somewhere here. Yeah.
I have one comment and one question. I totally agree with what you have said earlier. I treat cancer patients in a much developing country. Having used this technology in the internet, we use different guidelines. We use combination of chemotherapy, radiotherapy to treat cancer. Most of the cases using palliation, but in some cases it's curative. So I totally agree with having new guidelines. I can get the guideline from Norway in 1 or 2 minutes in Ethiopia. My question is, since both of you are researching in cancer therapy, we have came up with for the last few decades we knew about much of the pathways that's going on through cancer. So we know previously you mentioned like the P53 pathway, how it affects the cells and how cancer is developed. And we came up with different kind of drugs that target the different pathways. Those can affect the angiogenesis, the vascular so-called analytical structure. Different kind of pathways have been targeted, and this, let's say, very expensive group of drugs have been in market. I don't know, 5 or 10 or more. But on our actual clinical practice, we have seen that not the survival benefit is not that much. So
Yeah.
we know a lot of things about cancer over the past 20 years. We know how cancer develops, which mutations lead to cancer. And we have tried to put different targeted therapy, tried with immunotherapy. Now vaccination is coming up. In actual patient survival, much has been in cancer. So as a future researcher, so what do you think it will be the future of cancer?
Yeah. Well, would you go first? Huh?
No.
Yeah, I'll make just a short remark about that. As we said earlier, cancer, there are certain types of cancer which respond very well to the therapy, and the patients sometimes even never get cancer again. That's fantastic. Sometimes it requires expensive drugs, sometimes it doesn't. There are cancers which respond very well to, for example, metabolic adjustments. Since most of the cancers rely on anaerobic metabolism, there are certain approaches which use, for example, I don't know, dichloroacetate and the diabetic drug starts with M.
Metformin.
Metformin, right. To sort of jumpstart the cell's mitochondria. And mitochondria, in many cases, mitochondria will discover that something is wrong with the cell, release cytochrome C, and the cell self-destruct. So in some cases that works. We are today left with those cancers which are more difficult to treat. So naturally, they would require new solutions, and our old bag of tricks doesn't work that well. The problem of drugs being too expensive is what I just talked about previously. It is sensible for pharmaceutical companies to make a profit from their product, of course. However, I do not think that it is ethical to impose the same price of a drug all over the world and expect that everything goes well. In an ideal world, we would have a cheap drug by itself, but we would also be required to make a certain percentage of our GDP available to global funds, which would promote the discovery of new drugs and therapies. Currently, we are not living in an ideal world, and a lot of people will die not because we are unable to treat a disease, but because they were born in the wrong place at the wrong time. That is something I find devastating, but yeah, it's devastating.
Yeah, I'll also comment on that. I think so far in cancer treatment we have been, it's what we talked about previously, that we have been looking at cancer as one disease. So we've had chemotherapy, we have radiation that is very generic, and you just target everything. In a much higher degree now, we see that if you use different combination of drugs to target different vulnerabilities of the cancer cells, which is also targeted to the specific type of tumor that you have a much higher success rate. So I think that's the future of cancer research, is to tailor it more to that tumor cell. And because now still we have these generic treatments as a first-line treatment, and what you end up with is resistant cancer cells, which are hard to treat. But I think to a much larger extent we will also see that these tailored drugs will be the first line of treatment, and then hopefully we'll have a bigger success rate of actually curing someone, I think.
Yeah, investing more time into investigating the cancer of the patient, into really seeing how this thing works. Generic approach just doesn't cut it. Generic approach, like one size fits all, and that doesn't work with cancer. It has evolved to be as similar to your cells as possible, and yet different in this one thing, which gives it immortality. So,
and cancer cells are very unstable. Yeah. Their genome is just all over the place. So they will have, if they have a chance, they will have a new mutation to make them resistant as soon as possible. So yeah, I think it's important to go for the sort of the kill right away, and not push them too far to make them resistant.
Anyone else? Hannah?
I had a question about vaccines, since you briefly touched upon it. There are very recently been cases of measles outbreaks in communities where there's been very significant anti-vaccination sentiment. Do you worry that an anti-vaccination movement could grow bigger and have even bigger consequences in the future, or is that not?
I got, in my country we had the same problem. A lot of people, for various reasons, started suddenly rejecting vaccinations. I got very angry about it. And when I get angry, I'm no longer very courteous. So my response was, let them die. Like, let them die of preventable disease, because that is evolution. So if these people have decided, for whichever reason, political, ethical, religious, whatever, they have decided not to wash their hands before eating, then they should bear the full weight of the consequences of that decision. If somebody has decided not to take therapy, not to get vaccinated, and wants to get exposed to this risk, I think that person is engaged in a form of terrorism, if you will. So that may be too harsh, but I think that a problem which is so insolently assaulting everything that people like us have been working with our whole lives, such a problem requires an insolent response. So my response is let them die, really.
Yeah, I don't know if you want to...
Maybe have a more moderate approach to that.
I think I probably have a more moderate approach.
I was just outraged by those people. Anyway.
But I agree with the principle, though. It's terrible that some people actually they go to war to give people vaccines. And
absolutely.
In this part of the world, they have the luxury to actually say no to something.
Yeah, they take it for granted.
But what I hope is that now we see these outbreaks and we can maybe learn from that, and maybe this will be like a blip, and that we will see that let's not do that again. Yeah, I hope so. I hope people are rational about this.
You had a comment?
Yeah, just something that should be commented on this is the herd immunity. That is an essential part of the vaccination. That you said let them die, but the people that are actually dying from this could be like, I work with sick newborns, babies.
That's true.
That would be in a group of patients that would not be able to take vaccination. Already,
that's true. That's true.
So way I agree, but another way.
Okay, so then I'll modify my response. Let them die alone, far away from us. No. I think that the responsibility of each person to get vaccinated is just as important as the responsibility of each person to pay taxes. So, yeah.
If you could come and talk to the microphone, we can't hear it on the video.
Yeah.
Usually there are children that get vaccinated.
Can you talk in the microphone?
Usually there are children that get vaccinated. Do you think it should be mandatory that the government should say you have to get vaccinated, your child has to get vaccinated, you cannot decide this for your child?
Governments are great, but however, I don't think that they should be allowed to affect evolution. If somebody is so ready to expose its child to dangerous diseases, then let them. It shouldn't be mandatory.
The child has no experience.
Yeah, the child. That's right.
So should you let the child die?
It is not the child's problem that its parents are.
The parent will live, but the child will die, and it's not its own.
That's true. That's true. However, that's how evolution works. It's horrible, but yeah, it is very unfortunate for the child. But I don't think that whenever governments have too much control over people's bodies, that tends out to end up very bad for some reason. While I do find certain allure in the tyranny which would take care of everybody's immune system, I don't think that vaccinations should be mandatory. Because that creates a new set of problems. It might even, in certain societies, such as, for example, mine, it might form a sort of spite or resistance, like, the government is telling me that's because the, CIA nano probes from another planet are in those vaccines, so, they will control my mind. These things should not be mandatory. I think Norway has such a system, right? It's not mandatory.
It's not mandatory.
But it is expected that every person has enough common sense to wish the best for its child. At that point, you might even raise the question, is the parent acting in the best interest of the child? Sort of to put like the typical Nordic passive aggression onto the parents, but maybe mandatory vaccination is not the best solution. Education has always worked better than making stuff mandatory.
More questions? You?
Hi everyone, and thank you for a very interesting conversation. I've been following this from the stream, so I figured I'd mention that it's very difficult to hear someone if they ask a question outside of the microphone. But it's been very interesting, and I'm very happy that I did get the chance to see it through the stream. My question is to a topic you briefly discussed previously. It has to do with a movement called Publish All Research, which also includes negative findings. I suppose it's a two-part question. First is, would you, in your position, support this movement? And if not, why? Or why would one not want to? Let's talk a bit about the details as to why this is perhaps not a good idea. And secondly, is there particular responsibility, perhaps, that research in certain fields, such as this one, in which the repercussions could be potentially very grave, that it ought to be a specific focus to publish negative results in this field? Thank you.
Yeah, I'm not sure if you addressed me as a representative of some partly governmental agency, but absolutely we support open and transparent research and data and sharing, absolutely, in every way possible. How to achieve that? I mean, so journals, they of course, if you want to be a successful journal, you publish what people want to read. If you publish negative results, maybe it's not, the incentives are not there. But we see now, of course, we have the new Journal of Negative Results, I think it's called. So I think it's getting there, and people are appreciating more and more the value of also publishing negative results. And I think it's just it's this whole attitude change now in the scientific community. So it's going in that direction, and I think we will see more and more open access scientific literature.
Yeah, I think the Norwegian Research Council now requires that all research funded by it is open access or something.
Is it?
I know that at NTNU, I don't know at which level it's happening, but at NTNU now there are certain requirements that journals published. Why didn't I read that email? So there is a requirement that papers published by funding from, I think it was the Norwegian Research Council, I'm not sure, must now be open access. So that's a step in the right direction. And as for the negative results, I would probably be a best publishing author at that journal. The problem with science is that a lot of things that you do, if you're living on the very cutting edge of the science, a lot of stuff that you do is simply not going to be successful. It's either going to fail miserably or just, sometimes your experiment doesn't turn out as it should. Sometimes you have bacteria growing in your cells. But yeah, there should be a certain criteria of what counts as a negative result. So I just worked with this and then it spilled. Probably doesn't cut it, but we explored the effects of this particular compound on this cell line under these conditions, and it didn't work. Now that's already getting us somewhere. So yeah, with a little bit of criteria adjustments, I think it would be possible to make a body of, like, the Hall of Fame of the bad ideas. Which would save a lot of people a lot of effort. The downside being that if papers like this would be used as a measurement of a success of a scientist, you would have an explosion of scientific papers where they poured Coca-Cola into the cell lines and it killed them all. But it also didn't kill them in the patient, or stuff like that. So it may get absurd. But yeah, sure, why not? I would definitely like to go through the list of the experiments that people have tried before I go. It would save funding. Maybe that's the most significant thing here. It would save time, and of course that probably counts as funding as well. So it would save a lot of resources if you could see where other people have failed before you even start doing something. And yeah, maybe some of these things that failed for the wrong reason. Maybe the experimental setup was flawed. So yeah, definitely, but that's, I think, a discussion for itself.
Yeah, I think it's especially important when it comes to clinical research.
Oh, yeah,
Where you have treatments, where you have either stuff not working or you have side effects. That it's really important that you also catalog these effects and that people have access to them.
Yeah, because it's not good experimenting on your patients. Absolutely.
No.
Don't do that.
Okay, we had a question here, Osil.
You touched on it a bit with the vaccines, but I'm thinking about you can do all the research you want and develop all these amazing new drugs, antibiotics, vaccines, but it all depends on people, patients, trusting the government and the people who develop them for these things to be safe. Like my grandmother experienced lots of people dying of tuberculosis, so she was, of course, got all her kids vaccinated. But but like when another example is with the Ebola outbreak, some groups of people didn't want to do very simple things to prevent the disease from spreading because they didn't trust the officials who were trying to help them. Do you think there's a problem with the trust that people should have in medical professionals and governments and stuff like that when it comes to preventing and eradicating disease?
I think you're touching on something important. I think in Norway there is a lot of trust, especially when it comes to risk assessment and these things, that things should be relatively safe before they are tested on human beings. It's a cultural thing, I think, a lot of the time. I don't know if you want to add to that, but
Yeah, I'm just trying to make a parallel with my country again, because there are people who really distrust the system. But maybe that can also go under the thing with the evolution and extermination. I'm sorry if tonight I'm in this exterminatory mood, but yeah. It is important. Education is the first line of anything. You can talk to people and then explain to them the risks. That's the first rational level. Then you can explain them what can be done and how that works. But ultimately, I think it boils down to, to marketing, if you want. Because if you're able to do a good marketing job on your product and to explain to the people why that it is good, then you will have a higher likelihood of people getting vaccinated. But yeah, I don't think I have a clear answer to how these things should be handled. Education is the key. That is first and paramount. But reaching out to people and explaining to them that you are working in their best interest, it's a thing that varies from culture to culture, and sometimes it can backfire tremendously. And that's when accidents happen. That's when people die.
I think there is also a lot of people have a distrust in the industry. As soon as there is money involved, then people have distrust in that, and we see that also here. And if people are asked to hand out their personal data to the government or to the health authorities, then they have no problems with that. But if it's to the industry for drug development, then they are very restrictive of that. So it also depends on what level you.
Okay, anyone else? Yeah. Yeah, can you talk to the microphone?
Yeah, because we were talking about the cultural aspects and stuff, but also I think the historical aspects should be included here. Because I've been working in India for a year, and I've seen sort of how you can get an ethical clearance really easily to do some research that is not good enough. And if you, in many African countries, I don't have the reference of this, but I've heard that there's been a lot of research done on things that it's not done in an ethical way, and a lot of people have suffered from it. And if you have this history in your back, why would you trust new research? How should you suddenly trust something when in the past you have seen that research has been a really dangerous thing? So I think historical aspect as well, and we sort of should take responsibility to, keep it ethical.
Yeah, however, during preparations for this discussion, I was thinking a bit about ethics, and I mentioned that before the discussion to some of you. Ethics is... There is not one ethics. It's bad because it's pluralia tantum, but there are many different ethics. The ethics of one society are not necessarily the same as the ethics of other societies. There are societies which consider that sacrificing 10 or 100 people in a shady research, or in a research which is not that clear-cut on what its methodology is and what the outcome is, and how certain are you that these people will not die during your research. There are ethical systems which consider that a risk of a couple of tens of people is okay if that will bring the benefit to millions. It is difficult for us here in the Western society to understand that the life of the individual is not as important here as it is in other places. So this is something which is deeply connected to the structure of the society, to the moral norms of the society, and of course intimately connected to the histories of society. Individualism is a strong trait of Western societies. It is not like that across the world. There are places where it would be acceptable to make those risks if you have a possibility of achieving a greater good. I will not dare to comment on whether this is the better approach than the approach we have here, but both have advantages and disadvantages.
Okay, we have time for one last question. Anyone? Yeah, please come forward.
Okay, it's a completely different question about the eradication of malaria. And you talked about that you could eradicate the mosquito, but I heard about a different approach where you modify the mosquito so that you create a mosquito that is superior and that the parasite cannot survive inside. So is that a more plausible way to eradicate malaria, and what are the disadvantages?
Yeah, so that's true. There have been 2 attempts at the malaria mosquito. One is to eradicate the mosquito itself. The other is to make it resistant to the parasite. In regards to that experiment, they saw that it did not have the efficiency that they were quite hoping for, and it is expected because of this arms race. A parasite develops a lot faster than a mosquito, so they are expecting it to then be resistant over time. So it may not be as efficient as actually taking out the mosquito itself. So that's they think if you really want to use this as a viable strategy, then it's a more viable approach to take out the mosquito itself. People are also wondering why not use this gene drive for the parasite itself. It's not possible for practical reasons because it breeds inside one individual. It's not going to be able to spread it. So these are more technical questions, if you like. That's why.
And besides, we've become exceedingly efficient in exterminating animal species. We're doing it at an incredible rate. So you just wipe out the habitat, you poison the environment, and...
Yeah, I'll comment on that actually, because we also, in terms of mosquitoes, the Zika mosquito, we are working very hard to eliminate that as much as possible. In the 1950s, they almost succeeded taking it out completely in the Americas, not using genetically modified organisms, but using large amounts of insecticides. So the question is maybe not, should we take it out? Because we are trying to do that, but how should we take it out? What is the most sustainable approach of doing that if the goal is to actually take out the mosquito itself?
Thank you.
Okay, we have to end there. The time is up. But you are more than welcome to continue the discussion in Glassbaden or Bokcaféen upstairs. This has been an event hosted by Kulturutvalget. And if you are interested in more, this is actually the last academical pre-party this semester, but we have a debate next week called Skjult reklame og innholdsmarkedsføring, hva er greit? About commercial in journalism. And thank you so much for coming, especially thanks to you two, and cheers. Thank you.
To get out of this sofa. Sofa is very